always shy. Because it always gets sent to the wrong
Yeah.
one.
I understand.
Alright,
The right zip code.
here is number 17. Part 1 says sketch a graph. So we've listed some factoids about this graph, with the goal being to figure out how to draw it correctly. So let's take a look at the facts we have. I'm going to start with something really simple. I'm going to start with what looks like an algebra class and say, I've got some places that I have clearly defined points. I'm going to graph those points. So I have -4, -5. So -4, -5. I have -2, -4. So -2, -4. -1, -2. -1, -2. 0, 1. 0, 1. I have 1, -1. 3, -2. And 5, 0. This gives me a pretty decent idea of what this graph looks like, so let me make sure I do everything else correctly. It also says from -4 to 0 on the x-axis, it is increasing in concave up. So increasing would mean it has a positive slope. Concave up means it is opening upwards. It is the standard parabola shape, opening upwards. Concave down indicates the inverse or negative parabola shapes would be opening downwards. So again, concave up. I don't remember if I talked about this specifically what they look like. So let me remind that, and that may be a good thing to have for our notes. Concave up would be something like a standard parabola, like y equals x squared. And it's actually really easy to prove that that's concave up, because if I take two derivatives, I get a positive value. I would get an answer for y prime of 2x, for y double prime, 2. That's a positive number, so it is clearly concave up. Concave down is the opposite. So y equals -x squared. So y prime would be -2x, and y double prime would be -2, which is clearly making it concave down. So let's talk about how to graph this function. Increasing concave up. So it should open upwards in some form. Now, keep in mind, if my entire function opens upwards, it would look like this. So that means if only, like, this is also concave up. I want to make that very perfectly clear. That is also concave up. Okay? This by itself is concave up. Because again, if I was to use symmetry, it would clearly be opening upwards. So each piece is concave up, despite not having the entire thing being up. Whereas on the inverse, this one side is concave down, and this one side is also concave down. It's not about necessarily having a U shape, it's about the curvature of it. Is it curving in an upward direction? Is it curving in a downward direction? Okay, let's do it. Increasing and concave up. So increasing is easy. This means it has to go up over time, and clearly between -4 and 0 it is going up over time. But making sure it's concave up would mean that I want to make sure to have this nice, beautiful flowingness to it, like that. Drawing the same graph concave down is almost impossible, just because of the location of the points. If you try to make this concave down, that means you'd have to have a downward trend in between each one. So making it concave down would be almost like concave down, concave down, concave down, sort of. But then it runs into a big problem because it has places where it would then level off, so it wouldn't be concave down anymore. And so you can't actually draw it the other way unless you just mess up. Next thing it says, between 0 and 3, it is decreasing in concave up. Clearly decreasing. Concave up. And the last piece between 3 and 5. Concave up. Now you notice some things happen up here that will be talked about down here below. First thing I want to point out here. I chose to come to a point right here. I kind of have to. If I don't come to a point, I have to round it off. So think of what's going to happen if I round this thing off. Here I erase that, it'll become concave down, right? Because if I put that point back up here, if I try to round this point off like this, well, that becomes concave down right there, which is not what this says. It says concave up everywhere in there. So that means that this place right here has to come to a sharp point. Otherwise, it will not maintain its concave up. That's also why you see it's not concave with greater than or equal to. Because if it was equal to, then it would have to continue past it, and that's not what's happening. On the other side, the same thing can happen. Now, again, this one, it has to maintain its upward trajectory because it has to stay concave up. If it was to level off, it would no longer be concave up, it would be concave down. And so if you're looking at this would have one critical value at 0 because the derivative would be undefined. You might remember the derivative has to agree on both sides. If one side has a positive derivative, one side has a negative derivative, but they're not the same value or approaching 0, like if it's not leveling off, then it would be an undefined derivative. And over there at 5, we don't know if it's a critical value or not because nothing's told about what happens after 5. So it could, keep going, in which case nothing's happening special. Or it could, after 5, suddenly turn around over here at 6 or 7. And there'd be a critical value over there. Based on what I would have one critical value. Again, these are just general things you can notice about what's being defined by the function on 17. 18. Estimate the values of h prime of -2 and h prime of 1. So, let's talk about how we can discuss this information. Estimate the values of h prime of -2. Let's convert that into English. What is it actually asking me to do? When it says find h prime of -2? Slope of -2. So let's think non-calculus. If I was asking you to estimate the slope at -2, in algebra, you'd pick points around it and plug it into the point slope form or point the equation of slope, right? Y2 minus y1 over x2 minus x1. You can still do that for this problem. I could also take the limit from each side doing the same thing. So I could do the limit as delta approaches 0. And I get the same solution in theory. And so for this problem, one of the best ways to estimate a value of the derivative is by applying it like as if it's a slope question, not like it's a calc question. So here's what I'm going to do. I'm going to do the slope, so m of -2. I'd want to choose 2 points that are around -2. So I'm going to choose -4, which is 2 units away from -2, and I'm going to choose 0. I could choose -1, but I want to have some balance here in hopes it'll even everything out. I want to make sure to try to keep it as close as I can, and since I don't have one for -3, those are 2 that are closest while still being spaced evenly. Let's plug them in. The y values go on top, so my y value would be 1 minus -5 over, now the x value is on bottom, so that would be x value of 0 minus -4. So I end up with a value of, let's see, double negative makes it positive, so I end up with 6 on top, double negative makes it positive, which makes 4, so I get a value of 3 over 2. So that means the slope at x equals -2. It also wants me to do the slope at +1. Now in this case, I don't have the option of choosing 2 that are evenly spaced. I kind of have to choose 2 that are awkward. So for this one, for +1, I'm going to do the exact same thing. I'm going to do the slope at x equals 1. I'm going to do it at 0 and at 3. Try to estimate the slope there. So I come in here. I would do the slope at 1 is equal to. So I'd plug in the y values. So for this one, the y value at 0 would be 1. The y value down there would be -2. The x value would be 0. The x value would be +3. So I end up with +3 on top because it's double negative. I end up with -3 on bottom. Gives me a slope of -1. Now, do these values support the claim that h of x is increasing on the interval from -4 to 0?
Yes, because it's positive slope.
I would say, yeah, I agree. I'd say yes. Because
3 halves is greater than 0.
3 halves greater than 0, therefore increasing. Okay. Give a reason. That's a 3 halves greater than 0. You could also give the definition of increasing. You could say, by definition, increasing means the slope is bigger than 0, 3/2 is bigger than 0, therefore it's increasing. It's referred to as a law of syllogism in mathematics. That's going a lot more in depth, that's going a lot crazier, but it does work. 19. Determine the x values at which h of x is not differentiable. Give a reason why h of x is not differentiable at these values. So there's two ways to think about that, so I'm sad I have the picture gone. Let's see how well you guys remember. Determine the values at which x is not differentiable. That was at 0. And why was that?
Because the derivative is undefined. Because they don't agree, like it doesn't agree on both sides.
H prime of x is undefined. And then you could also say the limit as x approaches 0 from the left-hand side of f prime of x, sorry, h prime of x. H prime of x does not equal the limit as x approaches 0 from the right-hand side of h prime of x. Exactly what you said. So we could say the derivative itself is undefined. Why is it undefined? Well, the derivative on the left-hand side does not match the derivative on the right-hand side. Therefore, it does not exist. Now, what's interesting is you can also make the claim for two other places. Your endpoints. Why is that?
Because you don't have anything to determine the slope off of the
Other side,
other
right?
side.
Yeah, so we don't know if it's differentiable there or not because we can't ever have it on that interval. So the other way to say this, let's see. Determine the x values at which h of x is not differentiable. One way you can do this is determine the values where it is differentiable. So you might say from -4 to 0, union 0 to, I think it is at 4, I think. You might say, hey, this is where it is differentiable, so therefore everywhere else is not differentiable. It's one of those fancy things in mathematics that sometimes you are allowed to use the opposite to prove it's true. This is referred to as a proof by contradiction. You say, hey, I know where it is differentiable, therefore everywhere else must be not differentiable. Differentiable, as a reminder, just means you can take a derivative and get a solution. Undefined is not a solution. And those typically happen at jumps, asymptotes, holes, or places where you have a peak where the two sides do not match up. Or like the absolute value function at 0. Continuing on. 20. On what intervals of x is h prime of x greater than 0? Give a reason for your solution. I'm going to go back up. So when is h prime of x bigger than 0?
H prime.
H prime.
Where it's increasing.
Yep, that'd be the good way to say it. Well, it's increasing. So those two would be our solutions. So it asks us to put it as an interval. So my solution would be from -4 to 0, union 3 to 5. So far, none of these questions have asked us to take a derivative, really. Like, this is pretty common on these kinds of tests, especially on AP-style exams. And there'll be at least a couple questions on your quiz where I'm not asking you to use the equation. Some I will ask you to, because I want you to make sure you have those skills, you didn't lose them. But the rest is understanding the idea itself. Do you actually understand what it means when it says increasing and concave up, what that looks like in the picture? Do you understand how to graph points? The stuff that you need to retain. Do we need to do 21? 21, 22? Normal lines, tangent lines. As a reminder, what's going to be our first steps for each of these? Take a derivative.
Then you're gonna find your tangent line.
How do you find your tangent line?
You plug in your values, like your x values.
Your x value? Yep. Plug your x value of 5 for this one, and this one is backwards.
Yeah.
Don't forget this kind as well. It's asking where would the tangent line equal 4, not what's the tangent line at 4. So for this one, for number 22, as a reminder, I am keen on putting one of these on your quiz. This would indicate that you're supposed to find f prime first. And then what you'll do is you'll set it equal to 4 and solve. Because it's asking at what place is the tangent line equal to 4. And for this one, I believe there's 2 solutions. If it becomes a quadratic, you can factor it, and you could also use the quadratic formula. 23? Wait. It's 623. These are the ones that we've been working on. Determine the intervals on which the function is increasing or decreasing and the coordinates of any relative extrema. Show your analysis and explain your reasoning. These are things we've been working on. So, which ones do you want to go through? Any of them? All of them? None of them? What are your thoughts?
24 and 26.
24 and 26? Okay. 24. We're trying to find the coordinates of any relative extrema and determine intervals of increasing or decreasing. What's my process? Take a derivative. So I want to find g prime. How are we going to find g prime? You could distribute and then FOIL it out. You could also do a chain with a product. Or sorry, this would be a product with a chain. Yeah, it's weird, I know. Both would work. I think this is one that's I could probably bust out the foiling pretty quickly, and so you might be on the board with that, but otherwise I'm going to do the product and the chain. Since I have 2 components to do, I have a chain that is inside of this product, I'm going to do it by writing out all 4 components. So here we go. This is going to be my F, this is going to be my G, or you can call it A and B, or whatever you're going to call them. So I want F, F prime, G, G prime. So F is going to be the x plus 2 squared. G is going to be the x minus 1. And G prime is going to be left d right plus right d left. So if I can identify all 4 components over here, all I got to do then is just plug and chug and I'm good to go. Let's talk about each component. I'm going to do with a simple one first. G prime should be 1. Always get the easy ones out of the way while your brain's fresh if you can. F prime is a little tougher.
It would just be 2x plus 4, wouldn't it?
Yes, it would. So it would be 2x plus 2 times 1 is a full chain, but when you simplify, you get 2x plus 4. Yes. You bring the 2 out front, the inside stays the same, so that's why the 2's out front, and the x plus 2 is there. You then multiply by the derivative of the inside. The derivative of x plus 2 is 1. So I get 2x plus 4. Alright, let's do it. Fg prime plus gf prime. So it says we would do f, x plus 2, squared g prime, 1, plus gf prime, so x minus 1, times 2x plus 1. I want to make sure to put in parentheses. Don't forget. Now, it's asking us to determine intervals of increasing or decreasing. I might now want to FOIL out what I can and simplify because it might make it a little easier to determine the intervals of increasing and the intervals of decreasing. It's kind of up to you how you want to approach that. There are ways to get around it in this particular problem. It's just it takes a little bit of work to do. You gotta be real fancying with your factoring from here if you want to get it without boiling it all out. So I'm going to go ahead and FOIL. This first piece, 1 times anything keeps the same, so I have x plus 2 squared. That would be the perfect squared formula for binomials. Oh, you were so close.
Oh. Just x squared plus 4. Sorry. So.
Remember, it's a squared plus 2ab plus b squared. Okay, plus x minus 1 times 2x plus 4.
Plus 4.
2x squared plus, what did you say?
3x.
Matrix. You sure?
Sorry, no. My last number. I cannot do math in my head. This right, sorry, 2x, right?
Yep.
And then, sorry, minus.
Take a deep breath. You got this. I have faith in you. Alright. I'm going to simplify again. X squared and 2x squared becomes 3x squared. 4x and 2x becomes 6x. Positive 4 and negative 4 becomes 0, so there's our answer. Now this is a derivative. Yay! We're supposed to find intervals of increasing and decreasing. What's our next step once we have the derivative? Set it equals 0. Let's set it equals 0. Next. I can factor on an x.
3x.
Factor on 3x. What's left behind?
X 2.
X plus 2.
X.
Very good. So what are our two critical values that we have found now?
0 and negative 2.
So we have negative 2, 0. I need to pick numbers around or in between. I'm going to have to do 3 tests real quick. What numbers are we going to choose? Negative 5. Okay.
Negative 1.
Negative 1.
1.
1. Beautiful. Alright. Now, I got to plug negative 5 into the derivative. I can plug it into this version of the derivative, this version of the derivative, this version of the derivative, this version of the derivative. Remember, my goal is I want to determine positives and negatives. Okay, so whichever one you think is going to be easiest to do that with, choose that one. I know some people would jump at the chance to do the most recent one. That's where I'm at. But this one is also very good. Okay, you'll have to get a more exact answer faster. But again, our goal is to determine positive and negative only. So, negative 5 you suggested as our first number. So let's plug in negative 5. I would plug in this bottom one. 3 times negative 5 would be a negative number. 5 minus 2 would be a negative number. Sorry, negative 5 plus 2 would be a negative number. Negative to the negative would make this positive over here. So, from negative infinity to negative 2 is increasing. Plug in negative 1. 3 times negative 1 would make this a negative number. Negative 1 plus 2 would be a positive number. Negative times a positive would make this negative. So from negative 2 to 0 is decreasing. 1 becomes positive. Make sure to go back to the original numbers, your critical values. So these numbers are increasing. These numbers are decreasing. It also says determine the coordinates of any relative extrema. So that's where my critical values come back into play. I have negative 2 and 0 as my two critical values. What's negative 2 going to be? Why is it a max?
Because you have increasing from the left and decreasing.
Perfect. A max. That's going to be a relative max. Or also we call it a local max. Relative max at negative 2. You'll notice that I have done this a little differently. Instead of just putting x equals negative 2, because of a very specific word in my instructions, it says, and the coordinates. Coordinates means both x and y. So I can't get away with just giving negative 2. I have to also give the y value. Most missed point on this problem, by the way.
It's just 0.
Plugging in negative 2? Yeah, it's 0. And then I have a relative minimum.
0. Oh, sorry, no.
0.
Negative 4.
Negative 4. Man, that's a lot of work. A tiny little box, especially when I draw this big. There we have it. So most common things up here to have issues, well, you got to think it correctly. You didn't have to use the fundamental theorem of arithmetic correctly once you've simplified it down. And this may be a good problem where foiling out at the very beginning would have made getting to here easier, and therefore made getting to here easier. It kind of depends. You never know what's going to happen. Be willing to be flexible and try something different. If you would look at a problem, you're like, hey, maybe this time, you know what, I'm going to do it this other way. Once you've got your two critical values, make sure to test them using the first derivative test. Once you have that first derivative test done, we pick our three values, test around there, determines intervals of increasing and intervals of decreasing. And then make sure if your instructions state the location of any relative extrema, that's the x value. If it says the coordinates, that's both the x and the y, because coordinate means the point. The same holds true for 25 and for 26. Make sure when you find the min or max or whatever it happens to be, give the coordinate, not just the x. Most commonly missed points in the AP exam are not usually big fundamental things. They're usually, did you read the instructions correctly? Stuff like this pops up all the time, where there'll be like, one question will be like, hey, find the value. One question will be like, find the coordinate. And you're like, come on. It's just a small thing. But if you didn't read it correctly and you give the wrong answer, they're going to mark you wrong. Fine. And you said 26 as well?
I did, but I don't think we need to do it.
Well, anybody else? We have 25 and 26 available. Okay. Guess I'll keep going. 27. F prime of x is equal to x minus 1 squared times x minus 2 times x minus 4. Where is the graph of f of x increasing, decreasing, and or reaching any relative maximum or minimum? Show your work, justify your reasoning. Ooh, yay! 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 No? I thought that was pretty fun. Fake strawberry. F prime of x is equal to this function. Where is the graph f of x increasing, decreasing, and or reaching a relative maximum or minimum? Show your work, justify your reasoning. Woo. Intervals of increasing, decreasing, relative max, and min. What are we going to do first? Take a derivative.
I thought it'd be easiest to like keep your x minus 1 squared and then FOIL out your x minus 2 and x minus 4 and then do product and change that. No.
You would have already missed half of the points of this problem.
Oh.
What's happening here?
I already gave you the derivative.
Yes! I'm so sneaky. So sneaky. Just goes for practice. Whenever I was in your guys' shoes, when I was taking AP Calc, my teacher, what was his name? I can see his face, because I hated his face. He was the first math teacher I had that I knew for a fact was actually smarter than me. Like, this man was very intelligent. I'll have to find him someday. He would often say that for AP classes, assume the person writing the test is a jerk. Just rude, mean, assume he's trying to throw you off. Look for little details. Things like how you practice for an ACT help with practicing for an AP exam. Like underlining specific keywords and phrases, like stuff like that, because the most missed things in problems is stuff like that. We're going to just put the wrong thing down, or you're like, oh, it says increasing, decreasing. I must take derivative. I'm in that mode. Ah! It happens more than you would think. Everybody makes that mistake at least once. Okay? So in this case, we already have f prime. Note that fact. Now, with that being the case, how does that adjust what we need to do now? Set equals 0. Perfect. Now what? But there's 3 things. Fundamental theorem of arithmetic only works with 2 things, Mr. Douglas.
Damn lies.
Exactly. Okay. You're just having an off day here.
Positive 1, positive 2, positive 4.
Positive 1, positive 2, positive 4.
You just gotta take the square root of 0, make sure you get the plus and minus, everything from the block.
Yeah.
So the critical values are equal to 1, 2, and 4. We're going to see if they're going to be. Okay. So let's do intervals of increasing and decreasing. Let's pull out our number line. 1.
That's a great one.
My brain said 1. My mouth said 1. I wrote 2. I'll go with what's going on today. It's one of those days, I guess. All right, we're gonna pick numbers in between or around these these three. The 3 halves. That works. 0, that works. 5 works.
3 halves.
3.
No, what else are you doing?
3.
Seven.
You want to do like pi over 3?
Yes.
No.
Yes.
It really doesn't matter, because the cool thing about number theory is you can kind of work this out without ever needing to find the answer. So you can choose ridiculously complicated numbers, because the question becomes, is it going to be positive or negative, and that's what matters. Take a look. You want to do pi over 3? I love pi over 3. All right. 0. So if I plug in 0, I get a negative number, but then I square that, I get a positive number. Negative times a negative, so I have a positive times a negative times a negative. Positive times a negative will make it negative. Negative to negative will make this positive. Next set, 3 halves. So that'd make this one positive. Square it, it's still positive. 3 halves is less than 2, so that would make it negative. That make this negative. Positive times a negative to the negative. Positive. Plug in 3. Positive, positive, negative, negative. Positive 5, positive. So let's start answering our questions here, one piece at a time. Where is the graph of f of x increasing? So we write out, it is increasing. It is decreasing. So where is it increasing?
Negative infinity. 2.
Oh,
I did that wrong. Sorry.
Negative infinity 2. 1. What's happening at 1? It's going to level off briefly. Then it's going to kick right back up. Then from there to 2, it's going to kick back in. English words are. There's clearly a union between those two. All right, and then on the other end. Very good. I'm so glad you didn't say 5. The number of times it happens, you would actually probably not be surprised. It happens, okay? Don't let it put you down. All right? That's why you always see I go this way, is so I can always clearly see, hey, that's a boundary point, that's a boundary point, that's a boundary point. They're my critical values. They should give me boundaries. Okay? All right, decreasing.
2 to 4.
2 to 4. Beautiful. All right. So I've answered this piece, that piece, and or reaching a relative maximum or minimum. So I go over the list. Relative max, relative min. Where will I achieve a maximum? At 2. So when the x value equals 2. And then minimum? X equals 4. And as we already said, what's going to happen at 1? It's leveling off. So, because I can, I'm going to draw a rough picture of what this graph's going to look like, making sure to follow all of these rules. Beautiful, beautiful picture. Here's going to be 1, 2, 4. So, it's increasing until we get to 1. So it's increasing until we get to 1. It levels off, then continues increasing until 2. At 2, it then becomes decreasing. And then at 4, it becomes increasing again.
That's very aggressive.
Thank you. I worked really hard on that graph. Spent so much time.
Your child.
How dare you insult my child?
On the test once, the dumbest mistake I can remember was reducing the coordinates. I remember that. So it was 2, 4, and I was like, oh, so I have to divide by 2. And then I divided 1, 2, 1.
I'll tell you a true story. Good story, too. Academic team my senior year. I was on track to be all district champion for the most number of points scored. Because that was the year that math was like the highest percentage of questions ever. And like that made it super easy because I was the best math person in our area.
No.
The final, well, it wasn't the final game, that would have been poetic. The final day was districts, and it was during one of the games. Like I had just a brain fart, just a stinky, smelly brain fart. And the question was like, solve this quadratic, and so I was busting it out. It's like, make sure to reduce your answer to lowest
Grades
terms.
10, 11, and 12, if you have not picked up your student ID, go see your seminar teacher at this time. If you've had your pictures taken this year by Life Touch.
I'll do that.
It's a lot of ifs.
I have my
So I got my two answers. My one answer was 3. I was like, sweet, easy. The other answer was like 6/4. So I buzzed in. I was like 3 and 6/4.
Oh.
And the person is just staring at me because I've been acing every question. I've been nailing hard calc questions that randomly popped up that year. I was nailing these like trig questions that were like, here's part of the unit circle. I was like, got this. I was like 3, 6/4. And she's just
Oh no.
incorrect. And I was like, what? Like I literally yelled in the middle of the round because I had not missed a single math question all day. I was like, how am I wrong? I could not possibly be wrong. You're wrong. That paper's wrong. And then my buddy Greg, who's next to me, who's the other math person, he wasn't as good as I was. He's a very smart man. He just tapped me and he's pointing at the paper like, you're an idiot. I was like, ah! He's still crushed, but like it was an emotional moment for me. It was awful. It destroyed my soul.
At least you did this.
6/4.
Do you want to hear something stupid? Okay.
Always.
So I kind of mixed up polynomial and quadratic. I thought they were one. I thought they meant the same thing. So I was like, oh wait. So are you gonna? We were given a question. It was like x cubed minus x squared minus like a cubic. I was like, wait. So should I say quadratic and then if they cross me, I should say cubic? For some reason, I swapped the two words. It was a very bad day. I was so pissed at myself. One of I was like, I woke up the next morning and was like, I blame it on my algebra teacher. Because it was like, okay, there's two types of equations, this one and the other.
I'll tell you what, Michael.
Linears and quadratics.
Oh, I'll turn this off. I'll tell you what, Michael.